Hi everyone, I'm Giovanni Ruocco. In this short video I'll show how we take data from our Arduino device and send it via Bluetooth to our notebook and via MQTT to our broker ThinkSport. Since that ThinkSport is not able to forward messages to other clients with MQTT protocol, we used an external public MQTT broker named HiveMQ that is linked to ThinkSport. To manage data of Arduino sensors, I used CoolTerm, that is able to save the data in a text file. The Arduino, powered by a power bank, is composed by a proximity sensor, a button, a LED, a buzzer, and a Bluetooth module. Let's see how it works. After connecting the module to the power bank and starting the connection between Arduino and CoolTerm, the distance measured by the proximity sensor is about 180. If I put my hand on the desk, the distance sharply decreases, and if a measurement is under 10, the buzzer starts to ring. As we can see, by pressing the button, the LED starts to blink and the trigger goes to on. These data are saved in a text file and with a Python algorithm are sent via MQTT to HiveMQ and to ThinkSport. On Cloud.ThinkSboard on the device Look at Me, we can see the measurements in real time. If I put my hand on the desk, we can see how the distance decreases and the alarm variable goes to 1. On Telegram bot, we can see that every time I receive a positive value for the alarm variable, a message will be sent to the bot, in which is written the ID of the status that is under control. Now we simulate the same behavior from 4 simulated devices. These 4 scripts send a random distance between 0 and 150 every second. As we can see, ThinkSport received these values. On Telegram bot, it sent a message every time a device sends a distance measured under 10. We can notice that these messages are sent for different ID.
I'm Andre Vona, and I'm going to show the simulation of our project Look at Me. In particular, we have made 3 clients that will enact the behavior of the lights and the speakers for each statue that will be provided with our project. In particular, this client, which is the number 1, is the entry point for our project. As you can see, I have already started the clients and they are all connected, and once I will pull the trigger by sending this message along with other virtual data, the clients will start working. In particular, it will start working the first client, then the second, and then the third. So let us begin. As you can see, now it has started working, and now it's finished. We will move to the second one. At the third, it waits for the second one to finish, and as you can see, the simulation is over because all the 3 clients have played their role in the simulation. And now my colleague Andrea Gaetano Ferrara will show you the web application part of the project.
This is the Look at Me web application. It is composed by 4 tabs: Home, History, Info, and About. In the home page, we have a real-time distance control table, where for each statue, we have a real-time distance value, and if that value goes under 10 centimeters, an alarm goes on. In the museum room set form, we can choose one statue and set a room number for that statue to be in. In the History tab, we have an history distance control table, where we have the statue ID, the room number that the statue is in right now, and the number of infractions for the statue in the last 24 hours. In the info page, we have info about the application and the project in general, also telling what is happening in each tabs of the web page. Finally, in the about, we have information about the project and the team, also giving us important links such as our LinkedIn profiles and the GitHub repository of our project Look at Me.